So next we are going to look at another process variable, level. Okay. So when we say level, we are talking about the level of fluid, or the height of fluid in a vessel, in a container, in a tank. Are we getting it? So that is what we are actually looking at. So the height of fluid in a vessel constitutes level. So there are some process operations, okay, that level measurement and control is critical for us to get our desired product or our desired output. So we have different methods of measuring level in the process industry. We have the direct and indirect measuring method, or the manual and the automatic level measurement method. Okay, so let us look at it from the angle of direct sensing and indirect sensing measurement. We also have the single point measurement, or free flowing solid level sensing. Okay, so as you can see on your screen, you see this is a manual gauge. See the sight glass, okay, that gives you a clear indication of the level of fluid in this vessel. So as the fluid is rising, okay, the connection is done such that as it's rising, the pointer or the indicator on the side glass will also be rising to give us a clear indication of the level within the vessel. So that's the manual. We also have other manual type of level measurement, like the, as we will see later, the physical gauging, okay, by using either a dipstick or a dip tape. Are we getting it? To get a calibrated stick or tape, okay, to get the level of the fluid in the vessel. So we have other automatic measurement. We have those that transmit the radio frequency, okay. The radar system also transmits radio frequencies. Then we have the ultrasonic level detector, the magnetostrictive level detectors, okay. Then we also have differential pressure level detectors. Are we getting it? Okay. All of these, the thermal, the vibrating tuning fork, the thermal dispersion, the float switch, which is also a manual or a direct sensing method, okay. All of these, they are different methods that we can use to sense the level of fluid in our vessel or in our process. So let us look at some of them in a little bit details now. So this is the direct sensing method, which is the sight glass. So as you can see, the sight glass, you see that the sight glass work with the principle that the level of the fluid, since we have this sight glass or this column connected directly, okay, to the main vessel, you discover that the level of fluid in the vessel will equal the level of fluid on the sight glass, okay. So that will mean that this pointer or level indicator, its position will give us a direct reading of the position of the fluid in the vessel. That is what we are seeing here. You see the position of the fluid, okay, in the sight glass. So that gives a clear indication of the position of the fluid inside this vessel. So by merely looking at the sight glass, you see that you know the level is here. So when you extend, the level should be about this position. So this one could be calibrated too, okay. represent this particular the height of the vessel. So if you say maybe let's assume it's 2 feet here now. If it is 2 feet here now, 30 centimeter here, then here will be calibrated 30 centimeter. Or if here to here, the bottom to the top, bottom to up of this vessel is say 100 centimeters as an example, okay, or 30 inches. Here to here will also be 30. That's from here to here will be 30 inches. So here is calibrated to give us the various readings within that 30, that is between 0 and 30 inches. So if here is showing us that it is say 8 inches as an example now, okay, if here is 8 inches, it means that the fluid is at that level 8 inches within the vessel. So that's a sight glass, and it's a direct sensing method. Gives you a direct reading of the level. Another direct sensing method is the float. Okay, so you see, since this is a float, as the level of the fluid is rising, the float will be rising along with it. Okay, so you see the connection as it's rising along with it. This will be dropping to give us, especially you can see like here now, it will give us the direct reading on this calibrated scale. Okay, as the float is rising, this is dropping, which means the calibration will be from up down. If it is full, the calibration it will move down the scale of this calibration. This is another float. Okay, so as it's rising, you see that the spindle will move to full. Then as it's going down, the float will be falling and it will move to this end. Okay, when it is 1/4 full, half full. This is a clear example of what we have in our vehicle fuel tank. So this is another form of direct sensing method. So other forms, as we said earlier, is the dipstick. Okay, so most of our oil gauges use dipstick. So as you dip, you cock, you see that the level to which we have the oil or the fluid in the vessel will be marked on the dipstick. So since the dipstick, either if it is calibrated, it will give us the level reading. If it is not calibrated, maybe we have the range, okay, that we expect to, that is the low and the high. Okay, so we expect to be between low and high. So that will also give us an indication. So this is another example of a dipstick that is used on a drum. Okay, as you dip it, the level of the fluid in the drum will be marked on the dip tip also, okay, or the dipstick. So here we have another example that is used to measure directly the level of fluid or liquid in a tank. It's also the dip method, which is the dip tape. Okay, so here we have the plumb ball, which is a weight. Then this tape is calibrated. So the mark of it, the mark on it, together with the length of this plumb ball, will give us, as you pull it out. When you pull it out, you see the mark on it. It will give us a direct reading of the level of the fluid in the tank. So in doing this, you need to go up the vessel, the tank, to carry out these measurements. Are we getting it? So these are the direct or manual level sensing or gauging